Hello student, I am MD Ibrahim Khalil. Our today's topic is stress strain diagram. First we have to know what is stress and what is strain. Then we will go to the stress strain diagram. Now stress strain diagram. Okay. Then what is stress? Stress is equals to F divided by A. What is F? F is equals to force. That means when some force exerted on some area is created some stress actually. A is area. And what is strain? When a long wire is subjected to some force, it elongates, and this elongation divided by the actual length of the wire is called the strain. Strain equals to L divided by L. L is small l is elongation, and capital L is initial length. Okay, then comes to stress strain diagram. Moreover, you have to know that strain is a unitless diamond in unitless parameter because the unit of elongation is meter and unit of initial length is also meter. That's why these two cancels out. Okay. Now comes to our main point: stress strain diagram. Along x-axis, I will take strain as it is the conventional rule, and along y-axis, I will take the stress, and it is also the conventional rule. Okay, strain, stress. Strain is also expressed by epsilon, and strain is denoted by epsilon, and stress is denoted by sigma. Now, what is stress strain diagram? Okay. From the diagram, we can see that when we stress a long wire or a material, strain will increase. And after some time, if we relieve the stress, the elongation goes to the normal position. It continues to behave up to a certain point, which is known as a proportionality limit. And after that, we get the upper yield point, and next we get the lower yield point, and after that point, we get UTS, which is called ultimate tensile strength, and there and last of the point of our concern is breaking point, where all material breaks down. Actually, I will describe every of the point after the lecture. Then here is shortage of space. Then I have to eliminate some of our A is the proportionality limit. Proportionality limit. B is the upper yield point. C is the lower yield point. D is the UTS. E is the breaking point. Okay. this stress strain diagram is conventional stress strain diagram for all of the materials, and all of materials in the world, throughout the world, if it is ductile material or brittle material, follows this stress strain diagram. But in case of brittle material, it only follows up to the yield point, but if it is ductile material, it follows throughout the from origin, that means from 0 point to E point. But in case of the brittle material, it follows only O point to B point. B point is the yield point, and from the yield point we can see that there is a permanent deformation in the material. That is also shown in the graph. If we go to the origin from A point, there is no permanent deformation. That is actually there is no strain after relieving the stress. But in case of B point, if we go to the origin, there is no stress in that point, but there is also a strain that is called the permanent deformation. Permanent deformation in the material. Permanent deformation. Okay. That is up to that is our today's lecture. We will continue further in the next class.